Hey all, welcome back. This is me Monica Sharma and welcome to MS Bio Academy. And today we are going to talk about that how we can calculate the anti-log of any particular number. So in the previous video, we have discussed that how we can calculate the log value with the help of a log table and also without using the log table. Now here we are going to discuss that how we can calculate the anti-log table. Now in the previous video, I have given you a few tricks and few formulas in order to calculate the log value very easily, right? So if you haven't watched that, please check that link also. I'm putting the link in the description box also. You can please see there, and it is very easy calculation and very quick calculation for all of you who are finding it very difficult when you solve the questions related to in your chemistry or the mathematics questions. So please watch that, and if you haven't subscribed our channel, then please press the bell icon and subscribe. Hit the subscribe button and subscribe for MS Bio Academy. So let's start for today's video, that is on how to calculate the anti-log of any number. Now how are you going to proceed it? So what is anti-log actually? First of all, let's understand that. Now if I'm saying that I have told you that what is the log of 2 is, or you let's take it as simple, that what is the log value of 10. Log value of 10, we know that it is 1, right? So how I can write the anti-log of 1 is, I can write that anti-log of 1 is equals to what? Is equals to 10. So it is just the opposite of what the log value is. That will be the anti-log value of that particular number, right? So if I say that what is the log value of 100, it is, we know it is 2. So what will be the anti-log of 2 is? So anti-log of 2 is equals to 100, right? So it is just the opposite. Now these are the simple ones, okay? Now let's take the complicated one. So if the some number is given, which is like this one, 3.6345. Now how you going to calculate the anti-log of this particular number? So how you have to proceed it? See, you have to first break the number into two parts. Now how you going to break the two parts, this number into two parts? You have to break the number as 1 with before the decimal point and 1 which is after the decimal point. So I'm going to write here 3, and then here I'm going to write 0.6345, right? So I have divided, I have break this whole number into two parts, one before the decimal and one after the decimal. Now what I'm going to do, if you remember in the log table, in the log value number, when we are calculating, what we were doing, we were calculating the number of digits before the decimal, okay? So if there are 3 digits are present, we are calculating that before the decimal, and what we were doing, we were subtracting 1 from that particular digit, right? So that what we got is this number, right? Since we said this is just opposite of the log value, so that means in the anti-log, what is this 3 is actually? This is 3 is that actually telling you the number of digits which is reduced by 1, okay? So we can just add 1 here in case of an anti-log. So what we're going to do is we just add 1 here. So we will find that the number of digits which were present in the anti-log value before the decimal will be how many? The 4 digits will be present, okay? This is not the number, but this will tell you how many number of digits are present before the decimal in our final answer. All right, so this we will get. Now here, this is what, this is the mantissa which we got from the by looking into the log value, right? So this is what in the anti-log. Now we have to calculate the anti-log of this. So how we gonna use? We gonna use here in this case the anti-log table, okay? Just like in the log value we were using the log table to find the mantissa. Now here this is the mantissa is given, so we have to find the number, the value after the decimal, so we need to use the anti-log table here. Now similarly the anti-log table also we are going to use the same way. What we're going to do is after the decimal, whatever digits are there, we are going to use them. In the first we are going to use the pair of digit, that is 63. We are going to look the 63 corresponding to the column number 4. Then again we are going to look the 63 corresponding to the column 5 in the mean difference. So let me show you the anti-log table first, then it will be more. So this is your anti-log table, and here also this one column is there and it starts from 0 here, right? So look for the 0.63 in the fourth row we have to see first. All right, 0.6345 is our number. So what we're going to do, 0.63 in the fourth column, so it is 4305. That is your value. Now again see 0.63 in the mean difference in the fifth column. So fifth column will be where it lies. It lies 1 2 3 4 5. So it is 5. The value is 5 here. So what you have to record is you have to just see the value, this one, which is 4305 plus 5. So just add both of them. Now this is not the final value because we have to put the decimal point also. Now the decimal point, I have told you, it will be decided by this number which we have taken. This is the fourth number, means we have to put the decimal after the 4 digits. So 4 digits will be, you have to calculate from this here, first, second, third and fourth. So if after this you have to place the decimal point. Now since there is no number is there, so we can just quickly write that the anti-log value of this 3.6345 is 4310. You can also cross check with this thing that how this anti-log and log values are just entirely opposite of each other. What you can do is, since this is the anti-log value, so what you do is you find the log of 4310 and you will get the same number, which is 3.6345.